if you were to see a computer, a laptop advertised like this, and you look at the specs, and nowadays they're fairly normal specs, except for one thing. You look at the display here. This is a pretty large display, and it features something called an NVIDIA GT740M graphics and 2048 MB of dedicated video memory. Sounds interesting. Let's take a closer look at that and see what that actually means. Okay. And monitors and displays, usually with desktops, we call them monitors, and somehow when they're attached to a laptop, we call them displays. But basically, of course, they're the same thing. And we measure them diagonally from the upper left to the lower right, or the lower left to the upper right. And sizes range as small as 10 inches nowadays up to 27 inches or more. The technology used to create the image is called liquid crystal display, which is basically a very tiny way of changing the amount of light and the color of light that will go through the screen. Of course, you have to produce some light behind the LCD display, and that's produced nowadays by LEDs, light emitting diodes, very, very small devices which emit light. And in the older days, not too long ago, actually, we used tiny fluorescent tubes to create the light. Now we use LEDs. And you see nowadays in houses, people are slowly starting to use LED light bulbs because, again, they produce a lot of light. They're very efficient, and they're kind of expensive, but they're very efficient. In the long run, they actually pay for themselves. We measure the quality of the display by what's called resolution. That's basically just the number of pixels you have on your screen. And we measure it horizontally and vertically. Say, for example, 1024 by 768 pixels. That's 1024 pixels measured along the horizontal dimension, and 768 pixels vertically. Okay, and you multiply those out, and that's quite a few pixels, right? What is a pixel? Actually, just picture element. It's the smallest amount of a picture, okay? The smallest element in a picture. You think of it just as the dots on the screen. If you look really up close to an image, you'll see some dots. Each one of those dots is a pixel. For example, here's a white screen here, a simple white screen. And if we were to take a loupe, which is a very powerful magnifying glass, and just look at a certain part of the screen, okay, right over there. Look at that screen there in the circle and take the loupe and look. And this is actually what we would see. In fact, this is an actual photograph, what I took from my loupe looking at the screen. And you can see it's not white anymore. It's what? It's just combinations of red, green, and blue. And if you know from physics, if we combine those colors in the right way, we get white light. In fact, if you break up white light with a prism, you'll see combinations of red, green, and blue, a whole rainbow of different colors. Okay, if you look really up close, okay, that's an actual single pixel, okay, just one little element combining red, green, and blue. And by changing the amount of red, the amount of green, the amount of blue, you can form almost any color. It's really amazing how they're able to do that. Okay, good. Now, of course, the more pixels you have, the better the image. Okay, but if the more pixels you have, text will get smaller, and also the system will run a little bit slower because it has to pump more pixels up into the display, and it's more expensive. Okay, anything better usually is. All right, there's an example of the difference in resolution. Here's a fairly common trademarked image that you see a lot in low res, and then there's high res, of course. See the big difference between the two. And now, if you put more pixels on the screen, those pixels have to get smaller. And we measure the size of those pixels pretty much by the pitch, okay, the number of pixels per inch. And for years and years, most computer displays have been at 75 dots per inch. But Apple has come out with a higher dot pitch of 220 dpi on their MacBook laptops, and on their iPhones it's even as high as 326 dpi. And and a lot of other computer companies have followed suit. Samsung has a similar high density display as well. Now these pixels are so small you can't see them. Okay, you can't see them with the naked eye. You need some kind of magnifying device to see them. So of course they produce a really nice picture, really nice. Because of the popularity of things like iPads and tablets, more and more laptops are adopting touch screens, okay, which makes it easier to point out things. Instead of just using the mouse and the keyboard, you can just touch the screen as you can on an iPad. And this is very important for things like Windows 8. The Windows 8 operating system was really designed for a touchpad type system, a touch screen type system. So, and if you don't have a touch screen, it's much more problematic, which is a big issue with Windows 8. Okay, when you buy a computer nowadays, you usually will come with some type of video accelerator, which basically just speeds up the number of pixels going to the screen. Nowadays, we use a lot of video. We watch movies and TV shows on our computers, and we play a lot of video games. So it's important for most of us that we get really fast graphics. And the way to do this is with a video accelerator. Most low-cost computers nowadays have Intel graphics, the video accelerator produced by Intel, the same company who does the processor. But if you really want good performance, you should get a video accelerator from NVIDIA or ATI Radeon, which is a division of AMD. And those will really speed up the graphics. So if you're into gaming or you want to watch a lot of movies, which a lot of people do, be sure to get a good video accelerator. One of the features of the video accelerator is how much video memory it has. Video memory is a type of memory which is very fast. Okay, the regular memory chips inside our computers are pretty fast, but video memory is even faster because we want those pixels to go up onto the screen as quickly as possible. So its price sizes range now from like 64 megabytes on up, and basically the more you can get, the better. Of course, the price goes up as you get more and more. So summary, we have a typical configuration for a laptop now. It might be 15.6 inch display, which is a good size, measured diagonally, pretty big size. And it uses LED backlit, which is very common now. It's a low-cost, light-emitting diode backlit display. The resolution typically maybe 1366 by 768, meaning 1366 pixels along the horizontal dimension and 768 along the vertical, which is not that great. The dot pitch for this kind of display is going to be about the typical 72 or 75 dpi. But if you want something better, get a larger screen, 17.3 inches. Get a higher resolution, 1920 by 1080. Will give you a better dot pitch. And if you, of course, good to have a good video accelerator, in this case an NVIDIA GeForce GT740M. And look at all this dedicated video memory, 2048 megabytes. Okay, that's going to really scream. So if you want to play games or watch movies, this would be the system to get. Really good. Okay, that's it.